Dear students, we continue working on our post-lab questions, and we start at question 4a. How do solutions 8, 10, 11, and 12 show the properties of a buffer solutions? I'm giving you this hint. We have to compare changes in pH of solutions 10 and 11 and 12 to solution number 8. And then we have to compare changes in pH of solution 11 to solution 8. So why we have to do so? Solution number 8, this is our buffer solution, right? And so in solution number 10, we having some amount of this buffer solution and adding small amount of acid, hydrochloric acid. In solution 12, we adding small amount of a base to this solution, and see how the buffer resists changes in pH when we add small amounts of acids or bases. Solution 11 is opposite, because here we adding a sufficient amount of hydrochloric acid, 3 milliliters of 0.1 molar solution of hydrochloric acid to 5 milliliters of our buffer solution. So let's start working on it. First of all, we have to know the molarity of our acids and bases, right? So, and here is our system. We have NH3 on the left side reacting with water, forming NH4 plus and OH minus. Okay, and what about the molarities of our acids and bases? 15 mils of 0.1 molar solution. Let's do that. For NH3 and NH4, it will be the same for both of them, right? So it's gonna be 15 mils of 0.1 molar solution over 30 milliliters, because total amount is 30 milliliters, and we will get 0.05 big M. This is the molarity of NH3 and NH4. We will write it over here, 0.05, and here 0.05. This is the molarity of these solutions. Okay, we have already calculated that, and this is for the pH of solution number 8. We have to use the Henderson-Hasselbalch equation to calculate the pH of solution 8. And the formula is given. It is pKa plus log of molar concentration of a base over molar concentration of the acid. pKa is 9.25. Base and acids molar concentrations were already calculated. We found them 0.05 for both. So you will just plug in these numbers and find out the pH. Calculate the pH and compare it with your experimental result. Now let's talk about the solution number 10. When we add in small amount of acid to our solution, buffer solution. But before, we have to calculate the number of moles of our base and acid. Because when we add in hydrochloric acid to our solution, hydrochloric acid will react with ammonia. It will react with ammonia, and the amount of ammonia, the number of moles of ammonia will be decreased, right? It will be consumed by this reaction. However, ammonium ions will be formed during this reaction. So, and the amount of ammonium ions will be increased by the amount of hydrochloric acid. Amount of moles of hydrochloric acid. Okay, I think that's clear. So we have to calculate initially how many moles of NH3 and NH4 we had before adding hydrochloric acid. And also we have to calculate how many moles of hydrochloric acid we adding to our system. First, we have to calculate the number of moles of NH3. Let's do that. For NH3, number of moles should be calculated as the volume of solution times its molarity. So we have 5 milliliters of in our case not 0.5. We have 0.05 solution, right? In our case, right? So we have calculated that. So we have 5 milliliters, and I will convert 5 milliliters into liters right now. It will be easy for me to write it down using these calculations, just dividing it by 1000, right? So this is the value in liters, 0.005 liters times molarity. Molarity is calculated already, 0.05 moles per liters. Liters cancel. I will have my number as 0.00025 moles. Okay, initially in my buffer solution, I had this number of moles of ammonia. What about HCl? So for HCl, I have what? I have 0.0005 liters. So I divided 0.5 by 1000 and I converted it into liters times 0.1 moles per liter, and I got this small number 0.00005 moles, right? So I have calculated that because I have to know the number of moles of each. Okay, now I have to calculate the molarity of acid and a base. But let's start from a base. We're talking about NH3. Moles of NH3 we have already calculated, so it's going to be what? Let's see, what is the number? 0.00025, 0.00025 moles of acid. Also, I will not override it because it will be very inaccurate. We have already calculated this number of moles in the previous slide. And over 8 milliliters, I have converted 8 milliliters into liters because our solution, the volume of our solution is 8 milliliters total. That's it. That's going to be molarity of the base. Talking about acid, we're talking about NH4. Moles of NH4 initially present is going to be the same number of moles as NH3 because they have the same molarity, the same number of moles. Right? And plus moles of HCl, okay? Over 0.008 liters. This is how we calculate molarity of acid in the base. And then we have to plug in our numbers in this formula, okay? Solution 12. In the solution 12, we adding 0.5 milliliters of sodium hydroxide solution to our buffer solution. Okay, that means the expression will be the opposite to solution number 10. So molarity of the acid, the amount of acid will be decreased, negative. Molarity of the base will be increased by the amount of sodium hydroxide added. And then you will plug in these numbers in the formula and calculate that. Solution number 11. Solution number 11, it is what? In solution number 11, we adding a very sufficient amount of hydrochloric acid. And again, our hydrochloric acid will react with ammonia, right? So, and ammonia will be consumed completely because we adding a lot of hydrochloric acid, and something will be left after the reaction between hydrochloric acid and ammonia. We have already calculated the number of moles of ammonia, right? It's over here. And this is the number of moles of hydrochloric acid. We have 3 milliliters, which is what? 0.003 liters times 0.1 moles per liter. You will calculate the number of moles of acid, and it will be consumed by the reaction with the base, with ammonia, and something will be left. And of course, you have to divide it by 0.008 liters because the total volume of our solution is 8 milliliters. And you will find the molarity of hydronium ions. And then, since we're talking about strong acids, which is represented as hydrochloric acid, so you will find easily the pH of this solution. So the pH is negative log of H3O plus ions. That's it. This is what you have to do for these calculations. Question number 4C and so on. Questions number 5. You will be easily, you can easily answer those questions. Just check your result and compare your results and see what happened during these processes. And thank you very much for watching and enjoy the lab.